continuing our chapter unit 2, that is solution. In the last class we have discussed types of solution, that is ideal and non-ideal solution. In case of ideal solution, it obeys Raoult's law at all concentration. In this case, interaction before mixing is equal to interaction after mixing. Enthalpy change on mixing is 0. That is, process of mixing is neither endothermic nor exothermic, and also volume change on mixing is also 0. So this is for ideal solution. Next we consider non-ideal solution. Non-ideal solution means solution which disobeys Raoult's law are called non-ideal solution. In this case, interaction before mixing is not equal to interaction after mixing, and also enthalpy change on mixing is not equal to 0. That is, process of mixing may be endothermic, may be exothermic, and finally volume change on mixing may be increasing, may be decreasing, may be positive, may be decreasing, negative. So next we consider types of non-ideal solution. So today we have our first topics, types of non-ideal solution. Types of non-ideal solution. Now, non-ideal solutions are classified into two types. Number one is called non-ideal solution showing positive deviation from Raoult's law, and second one, non-ideal solution showing negative deviation from Raoult's law. So first we start non-ideal solution showing positive deviation from Raoult's law. Non-ideal solution showing positive deviation from Raoult's law. So again here we consider two liquids, one A and another B. So before mixing, here AA interaction and here BB interaction. Now A and B are mixed together to form solution where both A and B are present. Now here AB interaction. So before mixing, A interaction and also BB interaction, and after mixing, AB interaction. Now if interaction before mixing is more than or stronger than interaction after mixing, it is interaction before mixing. So this is interaction before mixing is stronger than interaction after mixing, then this is weak, these are strong. So weak interaction after mixing means more tendency to get vaporized, because interaction after mixing is weaker than interaction before mixing. So if interaction is weaker, then more tendency to escape out from the solution. So vapor pressure higher than value expected from Raoult's law. That is, PA greater than except PA naught and PB greater than XB PB naught. So again we consider two liquids, one A, other B. So here AA interaction in liquid A and liquid B where BB interaction. So these two interactions are interaction before mixing, and after mixing here A and B both are present, and here AB interaction. Now after mixing, AB interaction if weaker than AA and BB interaction, that is interaction after mixing is weaker than interaction before mixing, then there is more tendency to get vaporized. More tendency to get vaporized. So vapor pressure will be higher than the value expected from Raoult's law. So vapor pressure will be higher than value expected from Raoult's law. So let us take a simple example. So two liquids, one is ethanol and other is cyclohexane. So here first liquid is ethanol and second liquid is cyclohexane. Now in case of ethanol, so there is strong hydrogen bonding between each molecule. So this is one molecule of ethanol. This is another molecule of ethanol. So this is another molecule of ethanol. This is another molecule of ethanol. So hydrogen bonding takes place between different molecules. Hydrogen bonding takes place between different molecules. So this is in case of ethanol. Now there is strong hydrogen bonding. There is strong AA interactions. So this is interaction before mixing. Due to hydrogen bonding, there is strong interaction between ethanol molecules. Similarly, in case of cyclohexane also. Now, when cyclohexane and ethanol are mixed together to form solution, so since both are organic substance, so here a homogeneous mixture between two, that is A and B, is formed. Homogeneous mixture between two, that is A and B, is formed. Now when both are organic, so easily they are miscible and homogeneous. So when they are mixed together, it is when ethanol cyclohexane occupies space between different ethanol molecules. So here homogeneous mixture is obtained. So in this process, some of its hydrogen bond is broken. When cyclohexane molecule is added to ethanol molecule, so some hydrogen bond is broken. So as hydrogen bond is broken, means intermolecular force decreases. So intermolecular force decreases after mixing. So more tendency to get vaporized. So vapor pressure after mixing is more than that value expected from Raoult's law. So in this example, here we take two liquids, one cyclohexane and other ethanol. Now ethanol is a molecule where strong hydrogen bonding takes place between different molecules. So A and BB interaction is strong. Now when cyclohexane molecule is added to ethanol molecule, so some of its hydrogen bond is broken, so intermolecular force decreases. So as intermolecular force decreases, more tendency to get vaporized. So vapor pressure of solution is more than the value expected from Raoult's law. That is why in case of non-ideal solution showing positive deviation, this is called non-ideal solution showing positive deviation. So first characteristic of non-ideal solution showing positive deviation is interaction before mixing is stronger than interaction after mixing. Second one, none of the component obeys Raoult's law, that is, partial vapor pressure of each component is higher than the value expected from Raoult's law. Third one, since it is a bond breaking process, so it is energy absorbing process, that is endothermic. So del H is positive. Del H is positive. And finally, since intermolecular force decreases, so there is expansion in volume. So volume after mixing is more than volume before mixing. So change in volume is positive. Change in volume is positive. So if 5 ml of ethanol is mixed with 5 ml of cyclohexane, then after mixing, volume of the solution is not equal to 10 but more than 10. Means change in volume is positive. So what are the four characteristics of non-ideal solution showing positive deviation? First one, interaction before mixing is greater than interaction after mixing. Second one, none of component obeys Raoult's law. In fact, partial vapor pressure of each component is greater than value expected from Raoult's law. And third one, process of mixing is endothermic, that is del H is positive. And finally, volume change on mixing is also positive. So next we write characteristics of non-ideal solution showing positive deviation. First one, interaction before mixing. Is greater than interaction after mixing. Number 2, partial pressure of each component is greater than value expected from Raoult's law. Number 3, del H mix equal to positive, that is endothermic. And number 4, del V mix is also positive, that is volume increasing. So these are 4 characteristics of non-ideal solution showing positive deviation from Raoult's law. Next we consider examples of solution. Showing positive deviation from ground zero. So our first example is ethanol and cyclohexane mixture. Second example is acetone and carbon disulfide. Acetone and carbon disulfide. Third example is acetone and benzene. So in all three cases, interaction after mixing is weaker than interaction before mixing. Next we consider graphical representation. Of positive deviation. So vapor pressure against mole fraction. So at this point x a equal to 1, x b equal to 0, that is sum equal to 1, and here xa equal to 0, xb equal to 1, so sum it is 1. So this is value of A, decreasing, so ideal behavior. And this is ideal behavior, and this is ideal behavior. So this is ideal behavior when there is interaction before mixing equal to interaction after mixing. Now since here PA is greater than XA PA naught, so this is value expected from Raoult's law, which is greater than expected from Raoult's law, so dotted line, and here more than value accepted from Raoult's law. So here this is for A, that is PA. Again PB is greater than XB PB naught. So again so here dotted line represent ideal solution and bold line represent positive deviation. So positive deviation always higher than value expected from Raoult's law. So this is graphical representation of positive deviation. Dotted line represent ideal, bold line represent positive deviation. So next we consider non-ideal solution showing negative deviation. So this is all about positive deviation. Now we consider non-ideal solution showing negative deviation from Raoult's law. Showing negative deviation from Raoult's law. So again we consider two liquids, one A and other B. So here AA interaction and here B interaction. Now A and B are mixed together. So we get solution where both A and B present. So here AB interaction. So AA and BB interactions are interaction before mixing, and AB interaction after mixing. So in previous case, interaction before mixing more than interaction after mixing. Now reverse, interaction after mixing is more than interaction before mixing. So more interaction after mixing means less tendency to get vaporized. So vapor pressure of solution less than value expected from Raoult's law. Similarly, PV less than XV. So when A and B are mixed together, then interaction after mixing, that is solution, is more than interaction before mixing. So more interaction means less tendency to get vaporized. So vapor pressure or partial vapor pressure of each component less than value expected from Raoult's law. So to explain this, let us consider an example of acetone and chloroform. Excellent example of negative deviation. Now, this is structure of acetone and this is structure of chloroform. Now, in previous case, old bond is broken, so interaction decreases. Now here, new bond is formed, so reverse one. In positive deviation, old bond is broken and interaction decreases. Here, new bond is formed, so interaction increases. So as interaction increases after mixing, so less tendency to get vaporized. So lower will be the value of vapor pressure expected from Raoult's law. Now bond breaking process is always exothermic process. When two molecules or atoms combine and form a bond, so some energy is involved in the process. So bond formation process is always exothermic. It is energy liberating. Previous case, it is endothermic since it is breaking process. So here new bond is formed, and always when bond is formed, some energy is released. So process is exothermic. And since interaction increases, so there is contraction in volume. Volume decreases. So always final volume less than initial volume. So change in volume is negative. Since interaction increases after mixing, so volume decreases. So always final volume less than initial volume. So change in volume is negative. Change in volume is negative. So what are the four characteristics of non-ideal solution showing negative deviation? First point, interaction before mixing is less than interaction after mixing. Second one, partial vapor pressure of each component lower than or less than value expected from Raoult's law. Third one, process of mixing is exothermic, that is del H is negative. And finally, since contraction takes place after mixing, so volume change on mixing is decreasing, It is negative. So it is called negative deviation. So next we consider characteristics of non-ideal solution showing negative deviation from rounds. First characteristic, interaction before mixing A and BB less than interaction after mixing. Second one, partial pressure of each component less than value expected from Raoult's law. Third one, enthalpy change on mixing is negative, that is exothermic. And finally, volume change on mixing is decreasing, it is negative. So these are four characteristics of non-ideal solution showing negative deviation from Raoult's law. So next we consider examples of non-ideal solution showing negative deviation. First example, acetone and chloroform. Second example, chloroform and nitric acid or diethyl ether. Third example, HCl and water. Next we consider graphical representation of negative deviation. Sum to sum. So this is for ideal solution. This one also for ideal. This one for ideal. So dotted line represent ideal solution. And since here vapor pressure is less, PA less than except PA naught and PB less than XB PB naught, So graph will be UR. So this is for A, this is for PB, and this one for A plus PB. So here dotted line represent ideal solution, bold line represent negative deviation. Finally, differences between positive deviation and negative deviation. So what are main points of difference? Number one, here PA greater than XA PA naught and PB greater than XB PB naught. Here PA less than XA PA naught and PB less than XB PB naught. So this is first point of difference. Second point of difference, A and BB interaction greater than AB interaction. Here A and BB interaction less than AB interaction. Third one, pH mixing is positive, that is endothermic. Here pH mixing is negative, that is exothermic. And finally, volume change on mixing is increasing, that is positive, and here volume change on mixing is decreasing, that is negative. So these are four differences between positive deviation and negative deviation from ground slope. So this is all about ideal and non-ideal solution and types of non-ideal solution, that is positive and negative deviation. Thank you.